Hari Om, dear children. I am welcoming you all for today's science class. Before we start the class, I request all of you to sit straight, close your eyes, and do the prayer. Get ready to do Om chanting 3 times. Breathe in. Om. Breathe in. Om. Breathe in. Om. Sahana bhavatu Saganau Bhunaktu Saga Viryankaravavagai Tejasvinavati Tamastumavit Vishavahai Om Shant Dishant Dishantihi Hari Om Shri Gurubhyo Namaha Hari Om. I hope you're all ready with your classwork note, pen and pencil. Dear children, in the last class, we have started with the lesson water. And we have seen various heads on the topic water. Composition of water, electrolysis of water, laboratory preparation of water, properties of water. Under properties, we have seen many physical properties as well as chemical properties of water. I hope you have thoroughly understood with these concepts. Besides these, we have also seen water serves as a universal solvent. So, continuing the last class, we are going to see some more concepts based on water. So in today's class, we are going to know and differentiate about what is potable and non-potable water, and you are also going to understand about the different methods of softening of water as well as purification of water, and also you're going to know about the causes, consequences and control measures of water pollution. So in today's class we are going to see about what are the salts that are present in water and its uses, and you're also going to learn about what is potable water, how to purify water and water pollution. Let us learn one by one in detail. At first, we are going to see about dissolved solids in water. I request all of you to draw this diagram before you are going to see in detail. Just pause the video and draw the diagram. Look at this diagram. In this diagram, you can able to see a sample of tap water which is present on a clean watch glass, and it is placed over a beaker containing water. When you boil the water in the beaker, what will happen? The tap water which is presented above the watch glass will be evaporated soon. And after that, you have to wash the watch glass. Now you can see a number of concentric rings of solid matter deposited on the watch glass. So what are these? These are the dissolved solids left behind after the evaporation of water. So salts minerals, and impurities are the solids that are dissolved in water. So, is these dissolved salts are important for us? Yes. Dissolved salts are important for many reasons. So, they are essential for the growth and development of plants. They add a taste to water. They supply the essential minerals needed for our bodies. Most of the chemical reactions important for our living takes place in the cells of our body with the help of the water. Apart from solids and minerals, air is also dissolved in water. So air is present in dissolved state in all natural sources of water like river, lake, pond, etc. So the solubility of oxygen in water is higher than the solubility of nitrogen. Air dissolved in water contains approximately 35.6% oxygen along with nitrogen and carbon dioxide. Air being dissolved in water is important for many reasons. Let us discuss in this slide. So, air dissolved in water is important for the living organism to survive. Fish extracts the oxygen from the water and expels water through the gills. So, fish can survive in water only through the dissolved oxygen present in water. When you talk about aquatic plants, the aquatic plants make use of dissolved carbon dioxide for photosynthesis. Then carbon dioxide dissolved in water reacts with limestone to form calcium bicarbonate. So that the marine organisms like snails, oysters and all extract the calcium carbonate from calcium bicarbonate to build their shells. So these are some of the dissolved oxygen in water uses. Next, we are going to see what is potable water. Imagine you are swimming in the sea and by accident you swallow some seawater. How would you feel? You would probably feel like vomiting. So, the sensation of feeling nausea is because of a lot of salt in the water. So, this is evident that every liter of seawater contains 35 grams of dissolved salts, most commonly known as sodium chloride. So, this water we call it as a saline water, which is not able to, we are not able to drink the water. So, it is said to be non-potable water. So, if the water which is suited for drinking is called potable water. This potable water contains 1 to 2 grams of dissolved salts, mainly common salt. So, in addition to the common salt, there are some amounts of calcium, magnesium, potassium, copper and zinc are present. Let us learn more characteristics of potable water. If the water what we are using for drinking should contain these following characters. So all the potable water, drinking water are colorless and odorless, which means it doesn't have any color and it doesn't have any smell. It should be transparent. So it should be free from harmful microorganisms such as bacteria, virus and protozoa. So once you have taken infected drinking water, what will happen? It will lead to some diseases. The potable water should be free from impurities such as suspended solids. And it should contain more minerals and salts which is necessary for our body That's all about the characteristics of potable water. Now we have to move on the next topic, purification of water.
Earth is a watery planet, yet water is a precious commodity. Can you guess why? This is because just 3% of all the water available on Earth is fresh water. The rest, 97%, is saline water of the oceans. Out of this 3%, the surface water of rivers, lakes, or springs forms an even smaller percentage. Fresh water from various sources may contain disease-causing germs and impurities. Large-scale water purification is done before it reaches our homes. So, let's see the journey of water before it reaches our home. At the end of this module, you will be able to define and describe sedimentation, filtration, and aeration, describe the process of chlorination and adding disinfectants, describe the journey of water from the sources to our homes. Here is a simplified diagram of a water treatment plant. Fresh water from the rivers and lakes are taken through pipes to large water treatment plants for purification. In the first stage of purification, water is pumped and stored in large sedimentation tanks. Alum is commonly used as a coagulant which forces tiny particles of dirt to stick together and settle down. In the second stage, water is carried from sedimentation tanks to the filtration tanks. Here, water is passed through the beds of charcoal, sand, and gravel. This process removes the remaining suspended impurities. The third stage of purification process is aeration. Air is passed through the filtered water in the reservoir by a pump with air diffusers. The circulation of air reduces the concentration of taste and odor-causing substances. This process is known as aeration. Disinfecting is the first stage of the purification process. In this stage, water is carried from the aeration tank to the disinfectant tank. Adding disinfectants such as chlorine destroys disease-causing organisms in water. Ultraviolet radiation and oxidative chemicals such as potassium permanganate and ozone are also used for disinfecting water. What's next? Yes. Now the water is purified and ready to drink. This water is stored in the storage tanks and supplied in towns through underground pipes. Thus, water undergoes several processes before it reaches our taps as potable water. To make our tap water extra safe for drinking, we can follow some very simple methods in our kitchen. A simple filter directly fitted to the kitchen tap. Boiling. The process of killing harmful germs by boiling is called sterilization of water. Boiling the water for 1 more minute after it reaches a rolling boil makes it safe for drinking. Remember, if you need to use bottled water anytime, check for these. Bureau of Indian Standards, BIS mark. The seal is intact and there is no leakage from the bottle. The manufacturing date and best before date. Crush or puncture the bottle after every use to ensure that the same bottle is not used to refill water again.
From the video, you have understood that water is purified by these following processes: sedimentation, filtration, and sterilization. So, in order to safeguard ourselves, Once again, I'm requesting you people to always take purified drinking water. The next topic is about the hardness of water.
Hardness of water. In this module, you will learn about temporary and permanent hardness of water. If soap does not give good lather in water, the water is said to be hard. Now, what makes water hard? Well, calcium and magnesium ions present in water make it hard. Soaps contain sodium salts of higher fatty acids that serve to form lather. However, calcium and magnesium ions present in hard water react with these salts and form the corresponding calcium and magnesium salts. The resulting calcium and magnesium salts are not soluble in water. They remain on the surface of water as precipitates, commonly called scum, thus resulting in little lather. Calcium and magnesium ions in hard water are present as the soluble salts of calcium and magnesium, which may be their bicarbonates or chlorides or sulfates. When only bicarbonates of calcium and magnesium are present in water, the hardness of water is said to be temporary. Hardness of water caused by bicarbonates of calcium and magnesium is said to be temporary, as it can be easily removed by simply boiling the water. When temporary hard water is boiled strongly, calcium bicarbonate changes to calcium carbonate, water, and carbon dioxide. At the same time, magnesium bicarbonate changes to magnesium hydroxide and carbon dioxide. The resulting carbon dioxide escapes to the surroundings. On the other hand, the resulting salts, which are calcium carbonate and magnesium hydroxide, do not dissolve in water and thus form precipitates. The precipitates are removed by filtration, and this rids the water of calcium and magnesium ions. In other words, the water no longer remains hard. Another method to remove temporary hardness of water is Clark method. In Clark method, some amount of lime is added to hard water. Lime, which is chemically calcium hydroxide, reacts with calcium bicarbonate to form calcium carbonate and water. At the same time, lime also reacts with magnesium bicarbonate to form calcium carbonate, magnesium hydroxide, and water. The resulting salts, calcium carbonate and magnesium hydroxide, as you already know, do not dissolve in water and thus form precipitates. And once the precipitates are removed by filtration, the water no longer remains hard. Once that we have studied about the temporary hardness of water, let us now learn about the permanent hardness of water. You may have noticed a hard white coating inside the electric kettles, on showers, and even inside utensils in which water is boiled. This hard white coating results due to permanent hardness of water. The permanent hardness of water is caused due to the presence of chloride or sulfate salts of calcium and magnesium. The white coating seen on different surfaces is nothing but a deposit of these salts. Permanent hardness cannot be removed by merely boiling the hard water. It can be removed by certain chemical methods that include treating the hard water with washing soda and Calgon's method, ion exchange method, and synthetic resins method. Let us first learn how permanent hardness of water is removed by treating the water with washing soda. When washing soda, which is chemically sodium carbonate, is added to hard water, it combines with the chloride salts of calcium and magnesium present in the water to form their corresponding carbonate salts along with sodium chloride. At the same time, washing soda also combines with the sulfate salts of calcium and magnesium to form their corresponding carbonate salts, but this time along with sodium sulfate. The carbonate salts of calcium and magnesium do not dissolve in water and thus form a precipitate. The precipitate is removed by filtration that frees the water of calcium and magnesium ions. and once these ions are removed, the water no longer remains hard. Calgon's method uses calgon, which is the commercial name for sodium hexametaphosphate, to remove permanent hardness of water. When calgon is added to water, each of its molecules ionizes to give 2 sodium ions and 1 complex anion. The complex anion further loses 2 sodium ions and captures 1 calcium ion or 1 magnesium ion from the water in return. As a result, the calcium or magnesium ion of the water becomes a part of the complex ion and no more remains free. This way, the complex anions of calgon capture all calcium and magnesium ions of the water, thereby removing its hardness. The ion exchange method uses zeolite, also called permutate, to remove permanent hardness of water. Chemically, zeolite is sodium aluminium silicate and it is insoluble in water. When zeolite is added to hard water, an ion exchange process occurs between the two. During the process, zeolite loses sodium ions to the water in exchange for calcium and magnesium ions. This way, the water becomes free of calcium and magnesium ions and is left with only sodium ions, which do not make water hard. In other words, the hardness of water is removed. The synthetic resins method uses ion exchange resins to remove hardness of water. Ion exchange resins are of various types, but the ones used to remove permanent hardness are represented as RNA. These resins are water insoluble and work by exchanging ions when added to hard water. Such resins exchange their sodium ions with the calcium and magnesium ions of the hard water, thereby freeing it from calcium and magnesium ions. This way, the water no longer remains hard.
There are some disadvantages of hard water. Yes, it is not good for washing clothes. It forms scum with soap and detergents, which makes the soap ineffective and also spoils the cloths further. So it damages the utensils and containers in which it is stored and forms a hard layer. It forms scales on the machine parts used in industries and decreases their efficiency. Apart from these things, it also results in stomach diseases if consumed for a long period of time. Next, we have to discuss about an important topic called water pollution.
Hello, Professor.
Oh no!
Oh, sorry, Professor. I didn't know.
Benny, you should have been careful. I'll have to do it all again.
I'm sorry, Professor. By the way, what were you doing? See the color? It changed.
Yeah, I was performing an experiment which is now spoilt as I poured few more drops of chemical than needed.
Oh, so how did the color change?
The way your face color changed when you hit me accidentally. Chill. Color changed because of those few extra drops.
Oh, few drops can change the color?
Yes, Benny. Even one extra drop can spoil any solution.
Thank God this doesn't happen in our day-to-day life, or else someone like me will keep hitting people and spoiling things.
No, Benny, it does. It does happen in our daily life also, even with something as general as water.
Water? How is that possible?
Water can get spoiled by the addition of some undesirable substances. This is called water pollution.
Oh, Professor, I would like to know about water pollution and its sources.
Sure, Benny. Let's enter the world of science to know more about water pollution.
Oh, sure, Professor. Let's enter the virtual world.
Qualitative change in water due to addition of undesirable substances is called water pollution. The main sources of water pollution are industrial waste, untreated sewage, fertilizers, detergents, oils, pesticides, and litter. Industrial waste is the major water pollutant. Some of the common wastes like acid, alkali, and metal compounds are dumped in the rivers by chemical factories. Metal pollutants like mercury do not kill fish, but it accumulates in their bodies. Consumption of such contaminated fish leads to accumulation of metal in our body and results in hair fall, rotting of teeth, and even death. Lead is another hazardous water pollutant, but the most dangerous water pollutants are radioactive wastes from nuclear plants.
Oh, Professor, this is scary. Even we can suffer from hair loss and rotten teeth. Ew.
Yes, Benny, but think about those fish. They have no choice but to stay in that water.
And suffer?
Yes, and suffer. Suffer because of selfish human activities.
Professor, tell me more about water pollutants.
Sure, Benny. Now let's zoom into the virtual world to impart some more knowledge to you.
Sure, Professor. Let's enter the virtual world.
Sewage is the household and municipal waste of a particular area. A large area of untreated sewage in farm waste is dumped into rivers and seas every day. The untreated sewage, which contains pathogenic bacteria, when added to water, causes diseases to humans and animals. Detergents and washing powder brighteners, which improve the whiteness of cotton and linen fabrics. These contain phosphates, a common pollutant. Many detergents are biodegradable. They can be broken into simple substances by living organisms, and this is not harmful to us. Some detergents are non-biodegradable, and their high concentration can kill fish and other aquatic life. Waste paper, plastic containers, food and drink cans form the next category of pollutants. They make the environment unclean and unsightly. Fish and small animals eat bits of litter, which causes choking in them and eventually results in their death.
Oh, this is shocking. Even wafer packets and cold drink bottles, they also are water pollutants.
Yes, Benny, not only that, but also the detergents that we use, any soaps, and even Yamuna River is getting polluted day by day because of all this.
Oh, all this is true. I have seen sewage and industrial waste flowing into River Yamuna.
Yes, Benny, you should also be aware about water and facts related to that. Let me brief you on some.
Sure, Professor. I would love to know.
On that note, let's enter virtual world again. Our planet Earth stands unique among other planets. This is because of the precious water present on Earth. Water is essential for sustaining all form of life. Food production, economy, and for general well-being. Water present on Earth covers 3/4 of its surface. Maybe you know that water is a renewable source of energy. Then, why do we need to worry about water scarcity? According to United Nations World Water Development Report 2003, actually 97.5% of total volume of Earth's water is found to exist in oceans. The remaining 2.5% only is fresh water. But even this total 2.5% of fresh water is not available for our use. Nearly 70% of this fresh water stays frozen at polar ice, glaciers, and permanent snow covers on mountain tops. Thus, only a small proportion of 30% of the total fresh water that exists on Earth is available for our use. This fresh water appears in the form of surface water and groundwater that is continually being renewed and recharged through hydrological cycle. Availability of fresh water is again reduced due to water pollution. Fresh water is polluted mainly by industrial waste, human waste, and also by agricultural waste.
I'm sorry, Professor. I didn't know about these facts. I won't waste water ever.
Not on anything?
No, Professor. I would use only what is needed.
I'm happy, Binny, that you understand and are reacting accordingly. This issue needs serious concern.
Professor, but what about the water that is already getting contaminated? It may be affecting human or maybe animals as well?
Yes, Binny, it does. Have you heard the news of death of black bucks recently?
No. Did they die because of water pollution?
Let me answer this. Do you know that nearly 13 black bucks died and life of 73 other black bucks were in danger in the zoological park in a city?
Oh, really? Why?
Yes, and all because of consumption of polluted water.
How did the water get polluted?
The water got polluted because of the sewage discharged from the nearby drain.
Who found that out?
A two-member team set up by Central Zoo Authority. They discovered during their evaluation that the water was plagued and polluted, which caused the death and illness of black bucks.
Sir, what exactly happened to the black bucks due to water pollution?
According to the zoo officials, black bucks were suffering from diseases like severe toxemia and intestinal infection.
This is terrible. Water pollution can be seriously very harmful.
So what is water pollution? Any undesirable changes takes place in water is known as water pollution. These are the major causes for water pollution: usage of household detergents, domestic sewage, domestic waste and plastics, agricultural activities, industrial waste, oil spills, and thermal pollution. This table gives you some of the common water pollutants and their sources and effects. The first pollutant is sodium sulfates and phosphates. It is present in detergents, which is very harmful for the human. The next one is plastic fibers and microbeads. These we are getting from plastic clothing and cosmetic products. When it mixes up with water, it gives some toxicity, so that some of the marine animals will get infected and results in death. The next common pollutant is DDT, dichloro-diphenyl trichloroethane, which is an insecticide where we are using in agriculture. From the agricultural field, these insecticides are washed away in the rainwater, and once it mixes up with the river water, we are using water for drinking. So, by prolonged consumption, it will cause damage in the brain of any insects, animals, as well as humans. The next common pollutant is nitrates and phosphates, which serves as a fertilizer. It also does the same as insecticide does. Apart from these things, nowadays our world is becoming an industrial world. So lot of industries are giving out lead, mercury, cadmium, chromium and arsenic. These we are getting from chemical industries, textile industries, leather industries, etc. So once this industrial waste reaches the freshwater like river water, ponds, pools, lakes, it gives some toxicity to animals, plants, and bacteria. Let us recap today's class. In today's class, we have talked about some of the dissolved salts that are present in the water and how it is useful for the humans. And apart from that, we have also talked about the potable water. Potable water is our drinking water, and we have seen water's purification of water and hardness of water and water pollution. I hope now you students can able to easily identify which water we have to use for drinking. And you have also learned the ways of removing impurities from hard water, and you can able to identify its application in your daily life. And apart from these things, the very important one is about the water pollution. So this we have to taken into consideration. So you have to understood the ways to control water pollution. Every drop will make an ocean. Like the same, if you are saving a drop of water today, it will become a oceanic in your future. So save water from your daily life activities. Thank you. Hari Om.
And become aware you want to be grateful to your eyes, and you want to do something good for your eyes. Open your eyes, look towards the right and towards the left, towards the right, left, right, left, right, left, right, left. Close your eyes, feel your eyes, and with each exhalation imagine you send relaxing energy, light energy from your abdomen to your eyes or through your eyes. Open your eyes again, look up, down, up, down, up, down, up, down, up, down. Close your eyes, feel your eyes, and with each exhalation send relaxing energy from your abdomen to your eyes and through your eyes. Open your eyes again. Now look to the upper right, lower left, 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 upper right, lower left. Close your eyes. Send relaxing energy to your eyes. Open your eyes again. Look towards the upper left, lower right, upper left, lower right, upper left, lower right, upper left, lower right, upper left, lower right. Close your eyes and send relaxing energy from your abdomen towards your eyes. Open your eyes again and make no circular movement clockwise. Look up and then slowly to the right and to the bottom and to the left and up to the right, down, and continue a few times. Try to make it complete circles and not just squares. This practice also helps to harmonize the two hemispheres of the brain. No, other direction, counterclockwise. To slow conscious movement. And slowly close your eyes and feel the relaxing energy of your abdomen go into your eyes. Now open up your eyes again and stretch out your right arm, thumb, the level of your eyes. Look towards your thumb. Look far away. Back to your thumb. Now look towards the tip of your nose, to your thumb, far away, your thumb, tip of your nose, thumb, far away, thumb, tip of your nose, thumb, far away, thumb, tip of your nose, thumb, and far away. Close your eyes, lower your hand, breathe a few times, and send relaxing energy into your eyes and through your eyes. Now, lift up your hands a little bit and rub your palms, warming up your palms and increasing the life force, the prana in your hand and your hand chakras. Put your palms over your eyes and feel the energy of your palms radiate into your eyes. Feel that calming, soothing, relaxing energy. Slowly relax your hands, lower your hands. And one more time, rub your palms, developing warmth in your palms, feeling the energy in your palms. And put your palms over your eyes and feel the relaxing energy of your palms radiate into your eyes. Slowly lower your hands. Remain seated for a few moments. Breathe a few times deeply. Feel the relaxation of your eyes, relaxation of your mind. You can do this wonderful breathing exercise every day. Your eyesight will improve. You don't need to get headache. And you come to clearer and clearer insights. Lisa and Sukadev wish you a day full of...
Purnamata Purnamitam Purnat Purnamudashyate Purnashya Purnamataya Purnameva Vashishyate. Om Shanti Shanti.